Module 6 dives into the intricate technical foundation underpinning NFT creation, deployment, and management on blockchain networks. It equips you not only with the theoretical understanding of blockchain programming principles, but also with practical insights into the software development lifecycle of NFTs, including smart contract coding, metadata handling, and platform integration. 1. Smart contracts, the backbone of NFTs. Smart contracts are self-executing code snippets on blockchains that define the rules and behavior of NFTs, definition and role. These contracts automate minting, ownership transfers, royalty payments, and other NFT lifecycle events without intermediaries. Common standards ERC721, the original Ethereum NFT standard supporting unique tokens with individual IDs and metadata. ERC1155, a multi-token standard that supports both fungible and non-fungible tokens within one contract, enabling batch transfers and more efficient gas usage. Structure and function, breakdown of contract components, functions, events, and state variables, and how they control NFT behavior. Programming languages, Solidity, Ethereum, Rust, Solana, and others. Development tools, Remix IDE, Truffle Suite, Hardhat for testing, deployment, and debugging smart contracts. 2. Metadata and token. URI metadata holds descriptive information about the NFT and is critical for its identity and utility. On-chain versus off-chain metadata. On-chain metadata is stored directly on the blockchain, ensuring permanence but limited by size and cost. Off-chain metadata is hosted on external servers or decentralized storage solutions like IPFS, Interplanetary File System. Token URI. A unique uniform resource identifier links the NFT token to its metadata, typically pointing to a JSON file describing the art's attributes, creator info, and media links. JSON schema. Understanding how metadata is structured in JSON format to support standardized reading by marketplaces and wallets. 3. Minting process and deployment. Minting approaches. Pre-minting. Minting NFTs before sale, storing them in creator's wallet. Lazy minting. Creating NFTs upon purchase, reducing upfront costs. Deployment. Uploading and activating smart contracts on a blockchain network, making them accessible to users. Gas optimization. Techniques to reduce transaction fees, such as batching mint operations and optimizing contract code. 4. Interacting with NFTs programmatically. Web3.js and Ethers.js. JavaScript libraries enabling interaction between web applications and blockchain nodes, allowing users to connect wallets, view NFTs, and execute transactions. Wallet integration, using protocols like Wallet Connect and MetaMask APIs to enable seamless user authentication and transaction signing. Front-end development, designing user-friendly NFT interfaces for minting, browsing, and trading, often using frameworks like React.js. 4. Interacting with NFTs programmatically. Web3.js and Ethers.js. JavaScript libraries enabling interaction between web applications and blockchain nodes, allowing users to connect wallets, view NFTs, and execute transactions. Wallet integration, using protocols like Wallet Connect and MetaMask APIs to enable seamless user authentication and transaction signing. Front-end development, designing user-friendly NFT interfaces for minting, browsing, and trading, often using frameworks like React.js. 5. Security considerations, common vulnerabilities, reentrancy attacks, integer overflows, and unauthorized minting. Audit and testing, importance of thorough testing, formal verification, and third-party audits before deployment. Best practices, keeping private keys secure, limiting contract permissions, and implementing fail-safes. 6. Interoperability and standards. Cross-chain NFTs, exploring bridges and protocols allowing NFTs to move across multiple blockchains. Future standards, developments aiming to enhance scalability, privacy, and user experience. 7. Decentralized storage and IPFS, a peer-to-peer hypermedia protocol that allows decentralized and permanent storage of NFT metadata and assets. Pinning services, ensuring data persistence on IPFS networks. Alternative storage solutions, Arweave, and Filecoin. Learning outcomes for Module 6. Upon completing this module, you will be able to explain the structure and function of NFT smart contracts, understand the role of metadata and how token URIs link to NFT information, perform minting and deployment of NFTs on blockchain networks, use programming tools to interact with NFTs programmatically, identify and mitigate common security vulnerabilities, discuss interoperability challenges and decentralized storage solutions.